square root of 2 to the 1 power. And when we take it, okay, so let's go ahead and take a moment and make a prediction. So here, our modulus is, let's say, our modulus is, okay, let me think of a better way to put it. Okay, let's go ahead and start and get an entirely new complex number. Let's start from the beginning. 2 plus 2i? Let's make it a little more exciting. Let's do that 3, 4, 5. Yeah? It's a little more exciting. So, that's going to be 3 plus 4i. So we're going to go to the right by 3 and up by 4. Okay. What is the modulus?
5.
The modulus is 5. Okay? What is its argument?
63. 30. 30
over 3 at 4? Yeah, 60. 60 degrees. Okay. So here we started at 45, and what did we do each time? We went up by 45. So how much will it change each time? 60. So the next one will be 120. Great. Then 180. Then
40 to 300 to 360.
okay. Now hold up. So then for the modulus, how is it going to change each time? So if here's our point, if a is this guy, now here we know that the modulus is 5. We know that its argument is what? Okay. So what about a squared? What is its modulus going to be? Well, let's take a look. We take our starting modulus. A squared is going to be the square of the modulus.
25.
Oh, they're learning. Okay, great. Then what's our theta? 120. Okay, fine. Let's skip forward a few. What about 8 to the 8th power? What is its modulus and argument? How'd you get that? 5 square root 8. What?
5 to the 8th power.
5 to the 8th power. So 5 to the 8th power.
390 shows for 600.
I mean, yeah, I can also just write it 5 to the 8th power.
But
But if you want, what does it say it again one more time?
390,625.
125. Rad. Okay, now for this one, for theta, what do we do each time? What's happening each time?
120 times 4.
It's increasing by 60, so wait.
60 times 8.
Yeah, you're right. It's going to be 60 times 8.
480.
480. Don't get too excited now. Okay. So, let's go ahead and put all this together into one formula. Now, this formula, doing it with this in rectangular form is a bit of a pain in the butt because we have to first find the modulus and the argument. Yeah, I mean, it's not hard to find the modulus and argument, but still it's one extra step. Now let's go ahead and take a complex number in polar form. Okay, so I'm going to erase this. Is everybody good? Okay, raise your hand if you still need to copy this down. Okay, I'll give you 15 seconds. we taking r? What were we doing? Were we multiplying this? Were we taking to a power? What were we doing? R to the what power? N. N. It depends on our power here. Remember, we're starting with z to the 1, right? Is going to be equal to r to the 1 times all that mess. So this is really r to the n power. Okay? Fair enough? Handy dandy. Now what was happening to our argument each time? We were just adding another one on, right? What's it called when we repeatedly add?
It's
Multiplication. We're just repeated addition is multiplication. Come on, guys.
Oh yeah.
yeah.
Okay. So we're taking our theta, and this time we're multiplying it by n instead of taking it to the nth power. Okay. Yeah, so we just multiply our thetas. The same thing happens with the sine.
No.
We need the cosine and the sine to be equal. Or we need the insides of these guys to be equal, otherwise it throws everything out of whack.
I got a question.
Yeah, shoot.
When you multiply the modulus by the inside brackets,
Oh, you mean if you distribute this?
yeah, do you like distribute it and including the n power? You
Oh.
multiply the theta and n power, and then you multiply the modulus.
Okay, so I think that there's a bit of a misunderstanding about what we do with this thing. This is just a number.
Okay.
We don't need to worry about doing math to this number. I know that it looks really freaky. It looks like a complicated formula. It ain't. John, put that away.
Yes, sir.
Doesn't look away. Looks like it's on your lap.
Oh.
Away is over there in the back of the room. So now so when you're talking about distributing the r to the nth, when we do that, when we distribute the r to the nth, compute the sine and the cosine. What we're actually doing is that's us converting it back into Cartesian form. So if I was to choose, the process of computing this is just a conversion into Cartesian form. It's not something that we have to do every time. Okay, so let's go ahead and try an example of what this would look like. So go ahead and give me a modulus.
5.
Modulus 5, okay? Okay, modulus 2. We already did one modulus 5. Okay, give me an argument.
Pi over 4.
Pi over 4? Oh, she's talking in radians. I like it. Okay, well, let's just say pi over 4 degrees. Then I cry. Okay. So let's go ahead and take a number. Pi over 4 is 90 degrees. No, right? No, it's not. I'm sorry. It's 45 degrees. 45 degrees. I'm crazy.
Oh yeah.
Okay.
Oh, yeah.
Okay, so let's go ahead and take the complex number that has the modulus of what modulus do you want? 2? 2 times cosine of what?
Pi over 4.
Pi fourths plus I sine of what?
Pi over 4.
Pi fourths. So remember, this is just a number. We don't need to worry about computing the sines and the cosines. This is just an instruction manual. This is saying, hey, we have a complex number. Its angle, what's its angle? Pi over 4. Where's pi over 4? Give it to me in degrees.
Pi over 4,
45 degrees. So we have a point that's somewhere in that direction. How far in that direction?
2.
2. As far as it can go.
Yeah.
Okay, so 1,
Oh my goodness.
1,
Oh,
2. See what I'm saying?
this is a
I didn't even put a scale on here. Okay, so now let's go ahead and take z to a power. Oh, give me a power. What power do we give?
2 to the third.
3.
I like the 4.
Third.
Okay. So, if we're doing z to the 4th, what is its modulus going to be?
8.
It's going to be 2 to the what power?
4.
It's going to be 2 to the 4th power. What is 2 to the 4th power?
16.
2 times 2 times 2 times 2. That's 4 times 4. That is 16. So what would its modulus be? It would be 16. And what about its theta? It's going to be pi over 4 times what? Times 4. So what's pi over 4? What's 4 times pi over 4? Give it to me as a radian. Pi over 4 times 4 is pi.
Or actually, yeah,
5.
5.
Yeah? 180 degrees? Yeah? Pi over 4 times 4. 4 is canceled. 5. Yeah. There we go. So how can I get there? What's the angle for this one? The angle is for pi? Pi is 180. So we need to go over here. And how far this way do we need to